Hello, in this video we're going to see more examples of counting. So let's see this example. It says a customer at a fast food restaurant can order a hamburger with or without mustard, ketchup, pickle, onion. So we have 4 choices here for the hamburger. So like the hamburger, you could have without or with onion, without or with ketchup, without, and so on. So here we have 2 to the power of 4 or 16 choices for the burger. And the fish sandwich with or without lettuce, tomato, tartar sauce. So we have 3 choices for the fish. So again, with or without, and how many? Either you're gonna have fish with lettuce or tomatoes or sauce and so on. So we have 2 choices to the power of 3, which is 8 choices of fish. Okay, and then a choice of 3 soft drinks, or, and you remember, or is addition, 2 kind of milkshake. So we have 5 choices of drinks. It says how many different orders are possible if a customer can order at most 1 burger, 1 fish, and 1 beverage, but cannot order less. So where we have a person can order a burger, which we have 16 choices. He can order a fish by itself, 8 choices of that, and he can order a drink, 5 choices. He also can order burger and fish. So burger and fish, meaning 16 times 8. Also a burger and a drink, and that will be 16 times 5. And the last one, 2 of them, fish and drink. And so the fish 8 choices and the drinks are 5. So here first I have only 1 thing and then 2 things, and the last choice can be all 3, meaning the burger, the fish and drink, which is 16 times 8 times 5. So since we have all, so we're gonna add all of them, and if we add all choices we get 17 different orders. So this is how we break down a problem of counting. We see all choices we have, and if it is multiplicative principle, you will multiply, or you have or in between, then you add. Let's see the next example. Here we have what is the value of count after the following pseudocode has been executed. So we start with count equals 0, and we have 2 nested loops. So the first loop here for the counter I goes from 1 to 5. So I can be going from 1, 2, 3, 4 and 5. And then when I is 1, you go inside this loop, which gives you basically A, B, and C, 3. So when I is 1, you go A, B, C, and then the count start with 0. That means the count here become count plus 1. So when I is 1, you go A is 1, then the count become 1. And you stay in this inside loop here, and then you go back to B and the count become 2 and 3, and then you're done with the inner loop, and then you go back and I become 2. So we move here, and then the count keep adding 1 to it, because count is a count plus 1. That means 4, 5, 6, and then 7, 8, 9, and then at the end when I is 5 and the letter become C, you get the count result as 15. So at the end, what would be the count value? So the count is 15. So let's see this example here. Consider the set of 3-digit integers. So the numbers between 100 and 999 inclusive. So that means count 100 and you count 999. The question is how many are divisible by 5? 3-digit, we start with 100, and we're gonna go all the way to 999. And the question is how many divisible by 5? So for this number to be divisible by 5, the last digit here the third one here, must be either a 0 or a 5. So the choices we have, how many choices we have? So we have only two, a 0 and a 5. So we have two choices here. And for the second one here, you have from 0 to 9, which is 10 choices to choose from. And for the one, this 100 digit from 1 to 9, you have 9 to choose from. So this first digit, you have 9 to choose from. The second digit, you have 10, and the third digit, you have 2 to choose from, because either a 5 or a 0. So how many digits divisible by 5? That means it's a 9 times 10 times 2, which is 180. So we have 180 divisible by 5. So the same type of question now, how many are not divisible by 5? So it's very similar. The only difference is that the last digit here, the third one, so again, this last third one, we have 8 to choose from, because don't choose 0 and 5, not divisible by 5. That means we have 8 to choose from here, and then 10 for the second digit, and this first digit we pick 9. So we have 9 times 10 times 8, which is 720, not divisible by 5. So let's see a similar example here. We have 3 digits between 100 and 999. How many are divisible by 4 and 5 at the same time? So the same concept we're going to apply here. So for the number to be divisible by 4 and 5 at the same time, so for the 4 and 5, that means I need to have, the last two digits must be either 00 or 20, 40, 60 or 80. And this first digit here, you could choose anything from 1 to 9. So the first digit, we still have 9 choices. For the second digit, we're going to have either 0, 2, 4, 6 or 8, which is 5 digits to choose from. And the third digit must be 0, that means only one choice. So if I multiply 9 times 5 times 1, we'll get 45 that are divisible by 4 and 5 at the same time. Let's talk about decision tree. So as I showed earlier, when you have a burger with or without, this is very similar. Let's see this example. A tree that provides the number of outcomes of an event based on a series of possible choices are called decision trees. So let's see this example. Tony is pitching pennies. Each toss results heads or tails. How many ways can he toss the coins 5 times without having 2 heads in a row? So this is your first choice, this toss. So this is your first toss, the second, third, fourth, and fifth. So the question is, we cannot have head, or so on. So as you see, this first one is head. If I continue, it was head, and then each one of them have head, tail. So every time you have 2 or more head H's in a row, so we don't count that, because that's what the question is asking. So as you see, this is how you design the decision tree, and based off whatever decision you need to make, you keep going, and then you count all of them, so there are 13 possible outcomes. So this is kind of a very visual way of seeing all the outcomes. I hope this is helpful.